Hi, and thank you so much for clicking on this video, and welcome to integral of symmetry. Integral of symmetry is a new method in order to calculate any primitive of any function in any dimensional space. And in this fifth video, we are going to use our last formula, our second formula of the primitive of identity function and any power of it. We are talking about integral of s squared plus y squared, which is our identity function in circular expansion, with the power n dy circular expansion, and this is, as we saw in the last video, pi times s squared plus y squared to n plus 1 divided n plus 1. And we are going to use this formula in order to calculate the volume under this surface at sphere z equal f ds y equal root square capital R to square minus s square plus y square, which is the equation of the surface of the sphere between the two cylinders, which equation are the first equation, s squared plus y squared to the inner cylinder with radius r1 to square, and the outer square, which is equation, is s squared plus y squared equal r2 square. And only what we had to do is calculate the integral, the primitive of this function. We are talking about integral of root square capital R square minus s squared plus y squared from s squared plus y squared equal r1 squared to s squared plus y squared equal r2 squared. dy circular expansion. The way that we are used to calculate that primitive is the same procedure that we do in the traditional calculus. We are talking about the chain of variable. We want to introduce a new variable, u squared plus v squared equal r squared minus s squared plus y squared. And we know that this is our identity function, and the differential of that identity function is going to be the uv. We are talking about d u squared plus v squared is going to be d u v in differential in circular expansion, and is going to be the derivative, the differential of the expression in the equation, and knowing that the derivative of the r squared is a constant, for that is 0, and only we had minus ds y in circular expansion. Now we substitute this into our integral, and we had integral from s squared is no longer s squared. It's going to be now u squared plus v squared equal, when s squared plus y squared equal r1 squared, our new variable is going to be r squared minus r1 squared. To the our limit is going to be u squared plus b squared equal capital R squared minus r2 squared. Integral of root square of u squared plus v squared. Our dsy is going to be dub by negative. Okay? It's negative. Now we resolve this integral using our general formula, which is now m is going to be 1/2, which is the root square. From now we had this is equal to 1/2 plus 1, and we have pi times u squared plus v squared. 1/2 plus 1 is going to be 3/2. 3/2 divided by 3/2. And we have to evaluate it from u squared plus v squared equal r, capital R squared minus r1 squared, to u squared plus v squared equal r, capital R squared minus r2 squared. So we had 2 pi divided by 3. We open a bracket, and we had a minus. This is minus and minus, negative, sign of negative, and we have r, capital R minus r2 squared to 3/2 minus capital R squared minus r1 squared to 3/2. And this negative we can cancel it by changing the order of the factor into the bracket, and we had r1 minus r2. And this is our formula to calculate this volume. As you will see, it's a very easy and short way to calculate through this new approach. In the next video, we are going to calculate the integral of the e2 squared plus y squared dsy circular expansion. And we're going to see that this primitive of that function is going to be pi times s squared plus y squared. And we can use this result in order to calculate, for example, interval of minus infinity to plus infinity of s minus s squared ds equal root square of pi. Thank you so much. I hope to see you again in the next video.